Hey guys, today we are covering our last lesson in chapter 6. Isn't that exciting? We're almost done. Okay, so today we're going to translate the graph of an exponential function vertically and horizontally. Okay, so we're going to be looking at what h and k do to our graphs. We're also going to compare characteristics of two exponential functions represented in different ways. Okay, we might look at exponential functions in tables, we might look at them in graphs. So here we go, 6-5, transformations of exponential functions. And again, this is our last section in chapter 6. So here we go, vertical translations. So let's talk about k. How does the value of k affect the graph of f of x equals 2 to the x plus k? A big thing I want you to notice here, k is attached to the end of my function. Okay, it's just a number on the end. So let's start with comparing the graphs of 2 to the x plus 3 and 2 to the x minus 3 to the graph of f of x equals 2 to the x. So they've already done a really nice job and filled out for us f of x equals 2 to the x. So let's do g of x equals 2 to the x plus 3. Okay, so if this is 2 to the x right here, all we need to do is add 3 each time. Okay, so I get 3¼ 3½. Okay, 1 plus 3 is 4, 2 plus 3 is 5, 4 plus 3 is 7. So let's go ahead and graph these points. So -2, I get 3¼ So 1, 2, 3, and a little bit more. And I'm going to graph -1, 3½. 1, 2, 3½. 0, 4, 1, 5, and 2, 7. I connect those dots. Looks very similar. How did each of those points change? Well, go from here to here, here to here, I just moved up 3. Right, let's do another one. They said let's also compare, I think it's j of x. Yep, j of x equals 2 to the x minus 3. So again, I'm starting here, but now instead of adding 3, I'm going to subtract 3. This will be -2.75, -2.5. 1 minus 3 is -2. 2 minus 3 is -1. 4 minus 3 is 1. So let's plot these points. -2, -2.75. So that right here. -1, -2.5. -1, 2½. 0, -2. 1, -1. And 2, 1. Connect those dots. Okay, how did I get from the black to the blue? Well, looks like I went down 3. Whenever I have k on the end of my graph, it looks like it becomes a vertical translation. Okay, so the graph of 2 to the x plus k is a vertical translation of the graph. If k is positive, the graph goes up. And over here, the graph of 2 to the x plus k is a vertical translation. If k is negative, the graph moves down. Okay, so if it's positive, it moves up, negative, it moves down. Okay, that is what you need to know. You also notice a lot of things have changed here. Yeah, our domain, our range, and the asymptote might also change. So if I'm talking about the red, my domain, again, remembers how far left, how far right. My domain doesn't change. It's still -infinity to +infinity, or all real numbers. My range, however, does change. Okay, my range, I can come up here to 3 and keep going up. So we say that is from 3 to infinity, or y is greater than 3. And also notice I'm getting closer and closer to this line. That's what we call the asymptote. The vertical asymptote, or excuse me, let me erase that, not vertical. The horizontal asymptote It's just the line y equals 3. Okay, normally, our domain is all real numbers. Our range is y is greater than 0. And our asymptote is y equals 0. Okay, so notice everything moved up 3. Okay, so domain does not change, range changes, and the vertical asymptote will change. Okay, so here's a few problems for you to try. Please pause the video and actually try these problems. See if you get them right. Okay, so part A, how does the graph of g of x equals 2 to the x plus 1 compare to y equals 2 to the x? Well, this plus 1 just tells me it moves up 1. Part B, how does the graph of j of x equals 2 to the x minus 1 compared to the graph of 2 to the x? Okay, on the end, negative, so it goes down 1. That's all you need to do. Okay, next example. Okay, this time we're looking at h. And the big thing to notice here, h is with the x. It's inside the exponent. So we're going to compare 2 to the x minus h with the graph of 2 to the x. We're going to see what happens. So let's look at h equals 5. So let's compare the graph of g of x equals 2 to the x minus 5 to the graph of just plain 2 to the x. You could do this with a table. Let's look at it on Desmos. I think it's helpful there. So here is y equals 2 to the x. Okay, we've seen that lots of times before. Let's look at what happens when I put minus 5 in the exponent. Okay, that's the blue line. How did I get from the red line to the blue line? Well, we got 1, 2, 3, 4, 5. Okay, we moved 5 to the right. Okay, so this is the opposite of what you see. Okay, when I have a horizontal translation, it is always the opposite of what you see. If it's x minus 5, you move 5 right. If it's x plus 5, you move 5 left. Okay, remember we did this in chapter 3, so think back to then. We've done this before. Okay, and it's with the x, it's the opposite of what you see. Okay, and it's left or right. Okay, so if I'm looking at this one, j of x equals 2 to the x plus 3, I'm comparing it to 2 to the x, what do you think is going to happen? And remember, it's the opposite of what you see. So since it's plus, we're going to go left. We go left 3. Okay, that's all you need to know here. So let's compare the graph of each function. Okay, again, please pause the video and attempt these, and then let's see if you got them right. Okay, so the first one, g of x equals 2 to the x plus 2. It's with the x, so it's the opposite of what we see. So it's plus, so we say left, and it moved 2. And pause your video. J of x equals 2 to the x minus 2. Again, we're with the x, it's opposite, so right 2. That's all you need to do. Okay, now let's look at 2 different transformations. So let's look at this example. How can I compare the properties of g, which are here, to the properties of j given in the graph? Both functions are translations of f. So we want to compare g to j. So let's compare g to f first. So if I start at f, how do I get to g? Well, to me, it looks like each of those are 2 more. Okay, we're adding 2. So this just moved up 2. Okay, so g would equal 2 to the x, because that's what f is, and we moved up 2, so plus 2. Okay, now let's take a look at what j does. Okay, I'm looking at the graph now. Okay, so here's f, this is the blue. I want to know how I get to the red. Now you got to first decide, okay, is this moving left or right or up and down? Well, I look at each point on here. Am I the same distance up and down, or am I the same distance left and right? You should be saying up and down, because if I look right here, I'm super close. If I look down here, though, I'm not super close. So this is obviously up and down. So now we got to decide how much up and down. Okay, so let's pick some pretty points. This one looks nice. That one's nice. That one's nice. Okay, how do I get from the blue to the red? If I'm looking at these, it looks like I go down one. Because I go down one, that means j of x equals 2 to the x minus 1. Okay, I went down. So we now have enough information to actually answer the question. The question asks, how do I get from G to J? Well, I'm at positive 2, and I go down to 1. Okay, think about it. I'm up here at 2. I want to go down to negative 1. How many spaces are in between? So 1, 0. So I move once, twice, 3. So J is 3 down from G. Okay, so I got to compare two functions there. Hopefully that made sense. Okay, here's a couple try. Please pause the video, attempt them, and we'll talk about them here in a second. So 3a says the graph of the function b is a vertical translation of the graph of a of x equals 3 to the x and has a y-intercept of 0. Okay, so how does the graph of c of x equals 3 to the x plus 1 compare to the graph of b? So we know what a is, we know what c is. I got to figure out what b is before I can do the comparison. So a of x equals 3 to the x. Now this one doesn't have any vertical shifts. All of the time when we have no transformations, our y-intercept is 1. Okay, so a of x equals 3 to the x has a y-intercept of 1. So I know b has a y-intercept of 0. So how do I get from 1 to 0? Oh, we just moved down 1. So b of x, we want to move down 1. How can I make it move down? Well, I take my base function, so 3 to the x. I move down, that means it's just minus 1. Okay, so now I have b. Oh, now I can compare c to b. So let's start at b. I'm at minus 1. How do I get to 3 to the x plus 1? We just move up 2. So c of x is up 2 from b. Okay, let's look at another one. Again, please pause the video and think about it. Okay, so how does the graph of m of x equals 3 to the x minus 3 compared to the p of x equals 3 to the x plus 4? Well, how do I get from negative 3 to 4? Well, I'm down here at negative 3. I want to get up to 4. So negative 2, negative 1, 0, 1, 2, 3, 4. So 1, 2, 3, 4, 5, 6, 7 spaces. So p of x is 7 up from m of x. Well, that's all you have to do. Okay, so that's the lesson. Okay, remember, if it's a big number, it's a vertical translation. It's exactly what you see. Okay, so if it's a k out here on the end, if it's positive, it goes up. If it's negative, it goes down. Okay, and then remember, if it's with the x, it's a horizontal translation. And this is the opposite of what you see. Okay, so this was up, this was down. So if I'm plus 3, I go left. If I'm minus 3, I go right. Those are the big things to remember from this lesson. So here's your homework for tonight. Please look on page 250. You're going to do problem 16, 19 through 27 odd, and 30. Always, if you have any questions, please let me know. Hope you guys like this lesson.